Hi guys, hopefully this works okay. Here, a little background fan. Let me just see if I can get that off here. We're just moving on to Unit 4 here. So we're going to look at analyzing linear relationships. And I'm going to make 2 videos, I think, for this unit for Chapter 6 of the textbook. So first up, we're going to look at one of the most important things that you'll learn all year, or one of the things actually in 20 years, 30 years, 40 years, when you talk about math in high school, one of the things you'll remember for sure is this, guaranteed, y equals mx plus b. And that is what we call slope y-intercept form of a equation of a line. And what you have here is a y, which is a variable, and x is a variable. This is your slope. So we mentioned that last time a little bit. You guys know how to find slope a bunch of ways now, and this here is your y-intercept. So we have an equation, something like this, and that's a 3, if you can believe it. And eventually you'll tell me this has a slope of 5, and this has an intercept of -3. And then you'll be able to give some more information about that line based on this equation. Okay, so real quick, if we have an equation like this, you can tell me that the slope is 4 and the y-intercept is 1. When you have it, we shouldn't have gone right at this, but here, if you have something like this, that's the same as this, and that's the slope. That's the y-intercept. And what the y-intercept is graphically is where does the line hit the y-axis. Okay, so if this is 3, then the y-intercept is 3 here. Okay, if this is -5, this line goes like that, then the y-intercept is -5. This is the y-axis, right? The up and down one, and you can get it right off a graph. Okay, so for example, here, if I said, give me the equation of this line here, well, there's 2 components to it. I have y mx plus b. And each of these, you can have y and x just left as y and x for now, okay? And then you get the slope the way we did it before, rise 2, run 3. Okay, 2 over 3 is your slope, and that goes there. And this guy intersects at -5. It was a little more evident. I kind of made it ugly there, but that's where it goes. On this side, you get your slope as a half, negative halves, right? So you can go here and say, this is a bit of a difficult one, but let's say we had this point and this point here. You go over 1, down 2, that'll get you this here, okay? So your rise, no, that's wrong. That's wrong. Your rise is -2, your run is 1. So you have a slope of -2. So that means that you have an equation of -2x plus the intercept, and in this case it's 3. So your equation is y equals -2x plus 3. Okay, so that's that. A couple of special cases. I don't like the term special cases, but a couple of different lines. Okay, we got your horizontal line. Remember this guy here? We have a vertical line. We haven't talked about those in a bit. But this one here has a slope of 0. Remember I said if this was your roof, you have a slope of 0. So when you sub in a 0 into this equation, y equals 0x plus 4, because that's your y-intercept. 0 times x just turns into nothing. So you have the equation y equals 4. So anything of the form y equals a number, whatever that number is, a constant number, not a variable, but a constant, that is going to be a horizontal line, because it always has the same y value. It always has the same height. So if you look at the line, you look at it from a graphing point of view, okay, you figure out where you are on here, let's say -2, okay, and then you go like this, always -2, always -2, it never changes, okay. X, the value of x doesn't affect the value of y. I don't go up or down depending on how I've moved. This one here is hard to see, but there's your axis. See, this guy here is a vertical line. This one here is of the form x equals a number, and in this case it's -2, okay. So we can't look at this like this, because remember that a vertical line has an undefined slope, so this whole thing kind of goes into the garbage. Okay, so just remember that any sort of vertical line is x minus whatever. So it's always, The x value is always negative, or always plus 2 in this case. Sorry, that would just be x equals 2 plus 2. That's that line right here because you're always at 2. I'm never leaving, I'm never changing my x. My y changes, okay, but whatever my y is not dependent on the x. They're not related in this one. Okay, and then here, if you want to just do some examples, how do you get the slope? Well, you're gonna try to find 2 points on the line that are on whole numbers. Okay, so what I'm trying to say is that they intersect. They have an x and a y value that are whole numbers. So this is the point here, 2, 0. Okay, and that's right on there. And then if I go over here, that looks like it's on an up and down line and a side to side line. So that'd be the point 1, 3. So if I want to get the slope of this guy, I'm going down 3 over 1. So I get a slope of minus 3. I did it a different way in class maybe. On my note it's minus 6 and 2, but either way you're going to end up with minus 3. And then your intercept doesn't change, it's 6. Okay, so there's my intercept. There's your slope, there's your intercept. And you just do that for different types of questions. Okay, if you're going to graph, it's almost the same sort of thing. So this guy here, almost the same thing in reverse actually. This is your y-intercept, so if I was going to plot this at minus 2 and have a slope of 3 over 4, that means I rise 3, 1, 2, 3 when I go over 4. I have 2 points. I then connect those 2 points with a straight line, and then we always draw the arrows on the end. Okay. You want to label the line. In this case, you can just call it A. If it had an equation, this one here would be y equals mx plus b. That becomes 3/4 x minus 2. So you could write 3/4 x minus 2 also, if you wanted to label it that way. Okay, so that's how you plot the lines. Get your b value, and then get another point depending on the slope. Connect the points and call it a day. If you have a word equation, just be careful with your units. Okay. And here we might have a question here that we're talking about. We're trying to read this here, and we have deliveries and we have income. So this guy is making deliveries and he's getting income. And if we wanted to come up with an equation here, we could call this D, which equals the number of deliveries. And this one could be I, which equals income. Okay, and if we were trying to come up with an equation here, we could. But in general, what we're trying to do is just figure out what M is and what B is. Okay, so B would be this number here, which is 20. So you'd have 20 here as your B. And that would mean that if you made no deliveries, you would still make 20 bucks. So that would be your flat rate. And then the slope is here, it's going to be your y over your, it's always delta y over delta x. We look at units, it's going to be income in dollars over deliveries. So it's how much money you make per delivery. Okay, and we could figure out the slope here if we wanted to, and then we would come up with an equation. If we defined all our stuff, we could say income equals it'll be 20 bucks plus your rate of change, okay, plus something times your number of deliveries. So we could go ahead and find out what the slope is. The slope here, it looks to be up. If I have this point right here, I'm going up 10 and then over 2. So my slope would be up 10 over 2. So it would be 5. So I would have a slope of 5. So I would equal 5d plus 20 if I have y equals mx plus b. Okay, so again, we're just kind of using our equations here. We'll take our time on the word problems in general. They're all a little different, but you're doing the same thing. You're getting your intercept. Okay, it's not necessarily a y-intercept in this case. It's your income intercept. And then you're finding your slope depending on the situation, and then you're coming up with an equation that goes with that. Okay, so leave that for a bit. If you got confused on that, we'll do more word problems after, and just get used to the graphing. Okay, so here, once again, these are very similar to the ones we just did, but we're going to show here what happens is once we graphed all these. So this guy here is negative 1/2 x plus 8. I'd start at 8, and I'd go down. I'd go down 1 over 2 for my next spot. Okay, my rise is minus 1, and my run is 2. Connect the dots, and I get this blue line, and that's E. And if I had done this guy over here, C is this one in green, And my drawings are horrible, but what you would notice is that this line and this line are what we call parallel. They wouldn't meet, okay? They run like two train tracks. They'll never meet. And if you do a bunch of questions and you find parallel lines and you go ahead and you figure out their slopes, what you figure out is that they have the same slope. Parallel lines have the same slope. And that's a fact, Jack. So they all have the same slope. They have different y-intercepts, right? Because this guy's up here and this guy's down there. But if they have the same slopes, they're parallel. Perpendicular lines meet at a 90-degree angle. So, for example, our x and y axis meet at a 90-degree angle. But some of these lines would also meet at a 90-degree angle. And let me just go over to the eraser and clean this up a bit, if I can. Oh, look at that. Heck of an eraser. And let's go over here again. Let's stick with the pink, I guess. And if I go back here, what you notice is this line and this line, they go ahead and they whack into each other. And that is line A, which has a slope of 2, and line E, which has a slope of -1/2. And what you'll notice on perpendicular lines is that the slopes are what we call negative reciprocals. So the negative reciprocal of a number is 1 over that number with a changed sign. So the negative reciprocal of a whole number is always going to be 1 over the number. And if it's a negative, it becomes a positive. If it's a positive, it becomes a negative. So, for example, if I had 8 minus 8, the negative reciprocal is plus 1/8. If I had a fraction, like 2/3, what you're going to do is flip that as 3/2. And then if this was a positive, this would become a negative. So you got to change that sign. If you happen to flip a guy that is a fraction like this, 6/1, and make 1/6, and make it 6/1, change the sign to make it a negative. If the base of your fraction is a 1, then you can just reduce that down to -6. Okay, so that is negative reciprocals and slope, and perpendicular lines and slope, and parallel lines and slope. So 3 and -1/3 perpendicular. 5 and -5. Careful, okay? It's negative. It's not a reciprocal though. Okay, it's the same number, so it's not parallel. It's not perpendicular. It's neither. Okay, 6 and 1/6. This is a reciprocal, but it's not a change in sign. So if you plot these, you might find something neat about them, right? But the truth is, they are not either perpendicular or parallel. Like this one here is parallel. So perpendicular we sometimes show like this, and parallel we can show like that. Parallel lines have the exact same value with the same sign. So -2 and -2 would look like that. Okay, so those are perpendicular and those are parallel. The last thing I want to do is just change this into standard form. Change the equation into standard form. It's another way to write an equation. It's not even close to as effective and useful as this. But it is used though. So they will use lines and when I say they, I mean the math folk will sometimes write a line like this. The key is that here you have y and an x, and here you have ax plus by plus c. You still have your y, you still have your x, okay, but these a's and b's and c's are different. So it's another way to write it. You don't get the info that you get from this. One thing I do want to point out is that there's no exponent on this x because and same as this, because these are all order 1 equations. They have a order of 1, which means that they don't have a squared or a cubed or whatever. They just have x to the power of 1, really. And that means when you graph them, they have the same first differences, blah, 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 all the stuff we looked at, the same slope, and they form a straight line. I shouldn't say blah, blah, blah. I should have said et cetera, et cetera, et cetera. Anyway, another way to write this in standard form. We always have integers. So if you find yourself with this as your equation, that's no good. We don't want fractions here. Okay, so you can get rid of those. If they come up, I can show you, but it's not a big deal. And the other thing is this. We can't have this. It says A and B cannot be 0. A is always positive. So if it's not positive, what you can just do is make it positive. And what you're going to do with that is, if that is a negative, to make it positive, you'd multiply this whole side by -1. And then you multiply this by -1. It's a little trick, kind of. And 0 times -1 is still 0. This times -1 is plus 2x minus 3y plus 2y. So you would change every single sign if that happens. Okay, so be careful on that. you ever have x being the number in front of x being negative, you can change the sign, but you have to change the sign on every single term here, okay? So what you're going to do here is, if you have an equation, all you're going to do is bring everything on the same side, okay? And what you want to do is bring it on the side where x is positive. It just makes your life easier. So in this case here, I have 2x on this side, 2x minus 3. I might as well bring the y over here and then just rearrange it, okay? So I didn't do that in this example here, but if you do that, you end up with 2x minus 3 plus y. Nope, sorry, minus y, because you bring the y over. And then if you rearrange it, you end up with this. So you always have something x, something y, and then a number, and this is set to 0. Okay. The reason this is 0 is because when you bring something, if you bring everything off from this side over to the other side, what you've left is 0 on this side. Okay. So if I subtract y from this side, bring it on this side, make it negative y over here, what I leave is nothing, which is represented by the 0. If you don't do this, like I just said earlier, if you moved it to the wrong side, okay, and I don't really mean the wrong side, but if you did, by accident, move it to the side where x is positive. Actually, I messed this up. This is all wrong. This is right, okay? You want to have the x first, okay? So here I have this 9x. I'm going to bring this over here. 9x brought over to this side. Y stays where it is, and then the 6 becomes plus 6 equals 0. If you brought this over to the wrong side, let's say I brought everything over here and ended up with this, minus 9x minus 6 minus y. Well, first of all, put the x first, then the y, and then the constant, and then again that's equal to 0. Multiply everything by -1 and change all the signs here. Okay, so that's how you do that. The x's come over. If they are already in some sort of either y equals intercept, if they're in standard form or any other form, you could rearrange them into y equals mx plus b form by just moving everything on the right side, on the way it should be. Okay, so here I have this here, minus x plus 2y equals -8. I bring the x's on one side and the constant, and I end up with 2y plus x minus 8. And then what happens is, in this case, when you get rid of this 2 by dividing by 2 on each side, this here I put not good, and it isn't good because I don't want this divide by 2. What you're going to, because that doesn't give me the slope and the intercept, right? That gives me a weirdness. That's kind of a little bit strange. What you're going to do is rewrite this as 1/2 x. So there's like a 1 here, right? So it's 1/2, 1 over 2, and then here it's -8 over 2, which is -4. All right, so when you have that sort of thing, you want to make sure that you don't leave it as a weird, like a big fraction. You want the fractions to be allow us to find out the slope and the intercept. Okay, so that's about that. Let me just rearrange this one with you here. Okay, so at the end I want y equals mx plus b. Remember, we should know what we're trying to do here. Because the y is negative here, I'm going to bring that over to this side to make it positive. So that leaves me 6x minus 15 equals 3y. If you'd brought the 6x over and the 15 over it, you'd be fine, but then you'd have a negative you have to deal with later. And then here I'm going to divide by 3, but I'm not going to do that, okay? Because if I do that, that's just going to be a weird thing. So what I'll do is 6 divided by 3 is 2, and 15 divided by 3 is 5. It's negative, and there's my equation. You don't have to rewrite it the other way. You can leave it like this, but if you did rewrite it the other way, you end up with this. There's your slope, there's your intercept, and then you can plot that. Okay, hope that helped. Hope that made sense. Take care.